All right, these are two questions on energy transitions in hydrogen, specifically looking at the EM spectrum. So a key concept you have to know is the difference between a joule and electron volt. So a joule is just, they're both ways of showing energy, but electron volts allow you to go to minuscule amounts of energy or interpret and show minuscule amounts of energy. And joules are just like your regular like kinetic energy, the unit that comes out of that. So the way I think about converting it is just big E over small e equals electron volt. And this is big E is energy in joules, and small e is elementary charge. And then that just gets you electron volts. So for this question, we are given electron volts. We need to find the part of the EM spectrum that the photon belongs to that is released from a transition event. So what we'll do first is convert that to joules, so we can use E equals HF. So 20.6 times 1.6 times 10 to the negative 19. And that's going to get you 3.296 times 10 to the negative 17. And so now what we can do is use E equals HF and find the frequency. Because remember, the frequency, we can convert the frequency to wavelength, which will thus give us the point on the EM spectrum. So if we put energy, if we rearrange and solve, we get 3.296 times 10 to the negative 17 over Planck's constant, which is 6.63 times 10 to the negative 34. That should get you 4.9713 times 10 to the 16. And converting to wavelength, we just do speed of light over frequency. So 3 times 10 to the 8 over 4.9713 times 10 to the 16. And that gets you 6.03 times 10 to the negative 9. And this, if you look at the data sheet, references the ultraviolet range in the EM spectrum. So that's the answer for that. And then our next question is where we actually have to find the energy of the transitions and like convert it ourselves. So what we should first do is note the equation we need. In this case, we need energy is 13.6 over n squared electron volts. So again, this is in electron volts. That's not something you multiply. It's just the unit here. N is the energy level that you're jumping to and from. So from here we get the first excited state. So the first excited state would be n is 2, to the ground state n is 1. And so we have to do negative 13.6 over 2 squared plus 13.6 over 1 squared, because remember minus is a plus. And that gets you 10.2. And then from here, again, this is in electron volts, so we need to convert to joules. So 10.2 times 1.6 times 10 to the negative 19 gets you 1.632 times 10 to the negative 18. And then again, same formula, E equals HF, you just rearrange, you get 1.632 times 10 to the negative 18 over 6.63 times 10 to the negative 34 is 2.46 times 10 to the 15. And that is the frequency of the emitted photon. Again, if you had to find a wavelength, you just do speed of light over frequency. But that's all you need for these two questions. So when you're answering the spectrum or the electron transition events for hydrogen atoms, basically just look at the energies required to go between energy levels. So with this question on the bottom, we had to find that ourselves, and then from there you're able to manipulate around, use E equals HF, use all the formulas in topic E in order to find things. And generally it will only be like wavelength or maybe some other specific oddity, but primarily just wavelength and finding it on the EM spectrum. But that's all. So see you later.